Thanks for coming, everybody. I hope everyone can hear me okay. I'm Nick Walker. This is my colleague Alex Plaskett, and we're going to talk a bit about Windows Phone 8. So, what is Windows Phone 8? It's Microsoft's latest mobile offering with significant changes since Windows Phone 7. It's currently third position in market share with quite a small share overall as far as percentages go, with Android obviously covering most of the market and iOS beating it. But currently more and more applications are hitting the market. There's a lot of ongoing development from big corporations trying to add stuff to the market. So I think that the market share is going to increase quite quickly over the coming months and years. And on top of that, a lot of enterprises are currently trying to enroll it and use it as a corporate platform, which will also drive up the share. As far as developer documentation and security, however, there's not that much. While MSDN is a really great source for functional development information, how to write a functional application, there's not a lot as far as security documentation. There's a lot of surface stuff, like kind of general recommendations on what to do, but as far as technical use of the APIs, there's really nothing at all. So this talk kind of aims to address this problem from two angles. One, things for developers to watch out for when you're developing a Windows Phone application. And two, how to perform as a security assessor, Windows Phone application assessment. So I'll give you a rundown of what we're going to talk about in general. So we'll talk a little bit about the background of Windows Phone 8 and how it differs from Windows Phone 7. How to perform an assessment, a black box assessment of marketplace applications, what's required in that assessment, and how to address weaknesses that have been found in the platform. We'll also discuss public research originating from the jailbreak scene and their impact on application security on Windows Phone 8. Talk a little bit about local data protection, application sandboxing, and local data storage, a little bit about encryption. And we'll also discuss both legitimate IPC mechanisms available to users and how to use them securely, and also discuss some public, not so legitimate IPC methods that have been discovered that kind of open up Windows Phone applications to security issues. And obviously no talk will be complete without a little bit about input validation. So we'll cover that. So a little bit more about Windows Phone 8 background. It's originally, Windows Phone 7 was based on Windows Compact Edition kernel. Windows Phone 8 is no longer based on Windows CE and is, for the most part, a direct port of the desktop version of the OS running the NT kernel. In comparison to Windows Phone 7, Microsoft removed the restriction that only OEMs can run native code. And now third-party developers have access to that, and the platform now supports running managed code using .NET CLR, native code using C++ and WinRT. It's also possible to write HTML5 applications, but they're also backed by the managed C# layer and XAML. So due to the move to the NT kernel, the security model is based on standard NT security primitives, such as tokens and ACLs. And it's the sandbox similar to Metro desktop applications and app containers, which are influenced by the capabilities that your application requests in the application manifest. So when you're developing a Windows Phone 8 application, this is kind of the screen you'll see in Visual Studio. And I'm just put this up to kind of show you the structure, a little bit about the structure of a Windows Phone 8 application. So on the top right, all the aspects of the application. The one that's highlighted is the app manifest, which defines various config options about your application, similar to the manifest you get on an Android platform. You request your capabilities in there, and all your IPC mechanisms are kind of defined in there. On top of that, you have the .xaml files, which are basically XML files that define your user interface. There's also aspects of that can define the ways that interface ties into the C# code underneath. And obviously underneath that you've got your .cs files that drive the actual C# managed code that drive the application. So These are the core security controls that you get access to on Windows Phone 8, and we'll cover those in more detail later. Standard sandboxing, code signing, and your exploit mitigations. So sandboxing itself and the way that the actual security model's derived is sandboxing is based around an app container model, which executes apps in separately privileged containers, which are provisioned at runtime based on the permissions that they request. So you've got the Trusted Computing Base, the TCB, which is basically the execution context for all trusted code, so kernel code. And the least privileged chamber underneath is where all applications execute, and your OS components and drivers, any parts of the OS that don't need to be run as really high privileged, are moved into this least privileged chamber to reduce the attack surface. Basically, all user land stuff runs in the least privileged chamber where possible, reduces the attack surface for privileged code, and moves as much as possible into these least privileged chambers. So these chambers are provisioned at runtime for your application based on the capabilities the application requests. So if, say, you request access to the SD card or sending outgoing SMSs, those will be applied to that container when the container started. And these capabilities are also filtered down to the file system, and registry access is also restricted using this technique. So basically it all filters down through this container model. So there are a few differences, however, when you're considering how an application is deployed. So the security restrictions applied to an application depend on how the application was actually pushed onto that device. So there's two ways you can do it. You can install an app off the marketplace, or you can develop or unlock your phone and side-load an application. So applications that are side-loaded face less restrictions when you're in the sandbox, in that side-loaded applications can modify another side-loaded application sandbox directory, including the install location of their binaries. So a side-loaded application can actually modify the code of another side-loaded application. So you have to consider that when you're testing a side-loaded app, it's not necessarily representative of an application deployed from a marketplace state. So that's something you need to consider when you're doing an application test. So as far as code signing goes, all OS components are signed by Microsoft, which offers you standard tamper protection, reduces your attack surface for malware, and restricts its privilege escalation so that you can be sure that when your application's running in a container, it's the environment's sane. No unsigned code will run. All marketplace applications have to be signed in order to be installed on a non-developer unlocked device. The slight difference is when you talking about a developer unlocked device. So the actual signing of the marketplace applications occurs not before it goes up to the marketplace, but during the marketplace ingestion process. At that point, all of the applications that go up to the marketplace are also protected using play-ready DRM, which is then stripped when it's installed onto a valid device. So the code sign-in seems to have a few discrepancies that we've not really got entirely to the bottom of. So native and managed code seem differently affected post-installation with post-installation patching. So tampering with managed code seems to work fine. You can, as long as you got access to the file system, which I'll talk more about getting later, you can modify the .NET and applications will run just fine, but any modifications of native code cause the app to crash. So it's a useful tool when you're talking about doing functional testing for things like certificate pinning in kind of the more secure applications. If it's in your .NET code, you can patch it out, no problem, and carry on with your testing. If you're in managed code, then if you're in, native code, then you're going to struggle and it's going to just crash on you. So we're trying to get to the bottom of that currently, and it's something we're looking at the moment. So obviously, with it being a mature platform, you've got your standard exploit mitigation protections that you'd expect to see on all of the other platforms like ASLR, NX, and your stack cookies. So as far as encryption goes, it does support full device encryption, but for some reason it's not available for personal use. So if, say, you've got a personal Windows Phone 8 device, there's no UI option. There's no way to access in the UI to enable full device encryption. And it can only be enabled when you enroll the device into a corporate environment. For personal users, however, there is something called the Data Protection API, which is, it can be used to encrypt specific pieces of data, but that's left up to the developer of those applications to be used. It's an API available when the developer's writing the application itself. There's some issues with the DP API that we'll talk about later, and you should be aware of these. So, in the context of normal marketplace applications, because of the sandbox, you've obviously got no access to another application's data or binaries. Marketplace downloads via pinned SSL, unlike Windows Phone 7, where on Windows Phone 7 you could sniff the connection between the marketplace and the phone and pull the ZAP, the application installation file from the stream with no DRM and extract that and black box test the application, that way start reversing there. There is, on the Windows Phone 8 marketplace, a manual download and install option, which allows you to put the ZAP itself, download the ZAP itself straight from the marketplace, stick it onto the SD card of the phone, and install that to the device. But the ZAP itself obviously has still got play-ready DRM until you install to the device. So you can't just extract the code and take a look. You first have to install it to a device. So does this mean that you can't black box assess an app because you've no access to the code? Well, fortunately, some OEMs have slipped up and allowed us to break the sandbox. So on the A2S, on the XDA forums, there's a guy called Wolf that has got full file system access to the A2S, and this is how it's done. So there's a capability called ID cap interop services, which it's a capability that you request as an OEM to provide slightly higher level of access to the device functionality. So things like changing the registry, you can do with that capability. Obviously, that's functionality that can compromise the security model. It's a problem. So for more info about this capability itself, I'm not going to cover that in much detail here because Alex has already covered that previously. You can have a look at the research that we've done into Windows Phone 7. If you just Google for that, you'll find it. So the Samsung A2S has a diagnostic application which isn't directly accessible. It's a hidden app which is used for, I'm sure it was used for debugging at development time. It contains a big bunch of functionality, including a registry editor, and it's obviously got the CAP interop services capability. So the registry editor isn't accessible through any interface at all. There's no way to directly access it. But through a vulnerability Alex will discuss later, the editor can be called directly and opened to make registry changes. So these two registry keys are the registry keys that say which user and data directory the MTP service serves its files from. So you exploit the vulnerability that Alex will talk about in a bit and modify these registry keys to change the MTP service to run a system, and obviously change the data directory to serve from the root of the C drive rather than just the standard user pictures and videos directory. Restarts the phone and it gives you full file system access to the A2S system. So now you can see everything on the phone. You can go start taking a look at the attack surface of marketplace applications that you've installed. Go and look in their application install path, which is available under C data programs and then a GUID. These GUIDs are not secret. If you go to the marketplace on a web browser and search for the application, the GUID for the app is actually in the URL for the application. So you can just extract that out and you don't have to go searching to find that. You can pull off all your managed and native code and then start reversing like any other black box assessment you'd do on another mobile device and find yourself some vulnerabilities. So a few little side notes. While command prompt's been removed or any remote admin kind of functionality from any of the devices that we've managed to look at, it's still possible to restore this in the context of a low-priv container because the WIM files, the Windows Update files, actually contain debug-signed versions of Telnet, Command Prompt, and FTP. You can just literally extract these from the WIM file, package it in with your application, and start these apps. You can't really do much with it, obviously, because you're running the least privileged chamber, but it's a start for future work. So I'm going to talk about local data protection now and go over the data protection API. So what is the DP API? It's been in Windows. It's been in Windows, since Windows 2000. It's designed to be as simple as possible. It's used in a bunch of Windows tools. It's used to store your Wi-Fi passwords, your RDP creds, and it's two methods in crypt32.dll. You got protect, which takes a plain text blob and will give you back a ciphertext, and unprotect obviously does the reverse. So that's where the native methods are, crypt32.dll, but that you can also, there's a .NET layer to access those in system.security.cryptography.protected-data class. It's AES 256 encrypted blobs, but it literally only deals with the encryption and decryption. It doesn't actually deal with any storage of that encrypted data. So obviously that is kind of left up to developers to store the data properly. So how does it work on a desktop? On desktop, it works differently to the phone. So on a desktop, the keys are derived from a user credential using PBKDF2. A per user keys derived and stored in the file system under their SID in the app data directory, which means because you've got a per user key, you can't access another user's data in their contact. So someone uses an application that uses the data protection API as one user. They store some encrypted data. It does, even though they're on the same file system, they may be able to access the files. They can't actually decrypt that data because the context is different that it was encrypted in. There's a caveat to this in that you can specify a flag when using the native layer to encrypt with the local system key instead of the user context key, which means that if you use that key, then any user on the local system can access it as it sounds. So on the phone, slightly different in where the keys are stored. They're stored on those directories there. But the issue is that we're not sure whether it's because they're running on the same user ID but different contexts, but all applications seem to use the same derived master key on the device. So one application using a data protection API in Windows Phone 8 can actually, should they be able to access that data, currently the only way you can do that is with a Samsung 8FS using the MTP bug. They can actually just decrypt an application's data. So should the sandbox be broken in the future, the data protection API kind of becomes more the data obfuscation API than anything at all. So it's something to watch out for. We're currently, because we're only able to test this on the 8FS, we don't really know if it's a device-specific issue, but it could, when the sandbox is broken on another device, we can confirm that and find out. So how can you kind of demonstrate this issue? We use crypto notes to demonstrate it as a really simple DPA API app. You use the app, wait for it to call protect on the data, and that will save a blob, an encrypted blob. You can write yourself a little application that calls on protect on that blob, and obviously you have to copy that out of the sandbox and put it into the sandbox of your own application. Just call the crypt, and you'll get back the plain text that you put in the crypto notes application. So how do you mitigate against this issue? Well, luckily the DP API allows a second passphrase to be passed as a second parameter. It's basically a developer-supplied extra key, which basically does a second pass of the encryption. So it uses the master key for the handset, and then rederives a key based on the password that's passed in the call to the protect or unprotect method. Yeah, that mitigates against the issue, but obviously that secondary key is obviously then security critical, and storage of that should probably not be on the device and should be stored elsewhere or got from a web service securely. Okay, I'm going to pass over to my colleague, Alex.
Okay, so Nick's talked about the data protection API. I'm going to talk about transmission security and the data when it's transmitted across the wire. So on Windows Phone 8, it supports TLS 1.0 by default. Whereas, like, if you compare this to iOS, iOS is on TLS 1.2 in the latest SDKs. So Windows Phone is a little bit behind like that. But there's no weak ciphers at all supported. Only ciphers of 128 bits or greater in key strength. The one big problem at the moment is there's no way to, well, on Android, there's a way to override certificate checking, and this is a common problem with Android applications where they override the validation function, and then using self-signed certificates, then the application just proceeds and ignores any certificate errors. But on Windows Phone, there's no actual way to do this. There's no APIs in the language in C# or WinRT to actually disable certificate validation. So this is a good thing, but it also means that you can't do things like client certificates, client certificate SSL auth, and also for high security applications as well. There's no APIs for doing pinning. Because you can't have access to the certificate chain, then it's really difficult to actually implement pinning in Windows Phone 8 applications currently. But saying that as well, like, there's a lot of applications at the moment which still don't support, which don't use SSL, applications which you'd really expect to be using SSL. So things like Instagram that do their past session tokens over clear text. And as I mentioned as well, that apps, if they fail to connect, then there's no way to actually proceed after an SSL error has occurred. So a user can't actually override this. So in summary, for transmission security, there's not a lot really you can say about it, other than there's a lack of control at the moment by developers. There's no way to specify ciphers. There's no way to override the validation checks. If you do want to implement pinning, then it's possible to use a commercial library, or you could implement it using Win32 APIs. The problem with using Win32 is it takes a large amount of API calls to actually implement SSL, and it's quite prone to making mistakes with the Win32 APIs. So the next thing is interprocess communication. So interprocess communication on Android has been a huge source of security vulnerabilities in Android applications. There's been, like, for a lot of Android applications, the attack surface is significant, and because of the IPC endpoints which are actually exposed. On Windows Phone 8, it shares similarities to iOS, where you've got file and protocol handlers to actually implement IPC. So, for example, Twitter, like, you can implement a protocol handler for Twitter, like the URI below. So to actually implement these protocol handlers, well, what you do is you define the protocol handler within the application manifest, WM app manifest. So you could say your PDF application handles the PDF file type, or you could implement like a protocol handler like, for example, Twitter or Facebook. And then you write a map URI function within your application which handles the input from the URI. You can also embed these within web pages, and so if you embed the link within a web page, it doesn't actually provide any prompts when the URI is triggered. So unless you've got two applications which register for the same URI, then this will automatically fire up the application and pass the parameters passed in the URI to the application with no user interaction required. So this could be a source of errors. from looking at the top 30 marketplace applications, it seems that most developers are aware of this, and this isn't really, and we've not found any vulnerabilities in this area so far. So that was the way of doing the documented IPC as specified in MSDN. But there's another undocumented way as well, which is, I've coined this term, it's called cross-application navigation forgery. And it's essentially forcing a navigation from one application to another application. CPU Guy discovered an issue with toasts, but I want to demonstrate how this can be used by an attacker and how it could be used to exploit Windows Phone applications. So, for those of you not familiar with toasts, there's a pop-up at the top of the Windows Phone 8 application. And then if you use a click to that toast, then it forces navigation to happen. So you can deep link within the application which has actually triggered the toast. So you can link to certain parts of the application. But there's a vulnerability in because there's an undocumented API method called shell post message toast. And this essentially it allows you to specify an app URI, which specifies which application has originated the toast and the path to the screen within the application. So this means it can be any XAML screen within the application which is navigated to. So it's essentially like Android activities, but on Windows Phone, using this method, everything's exported, and there's no way to lock it down currently. So you can trigger any XAML screen within the application and pass whatever parameters you want to this XAML screen as well. So if there's a problem in the handling of the parameters which gets passed, then an attacker could use this to exploit the application. So I started looking at applications to see if I could find any which were vulnerable to this type of attack. And this is a large OEM vendor which needs to remain nameless at the moment. But essentially what this does is it takes the parameters from the URI and triggers just a format of the phone. It just wipes the phone. So this is, so this could be abused by an attacker. It also can put the phone into automatic answer mode as well. So when a call comes through, then the phone will automatically accept the call and automatically connect the call. So this is an issue to demonstrate this type of attack. But really, in a more realistic scenario, would be an authenticated session in a foreground application, and then a background application could trigger the toast to force the foreground application to navigate and exploit the foreground application to do something malicious. So my thoughts were, well, surely Microsoft's marketplace validation will detect this kind of thing as well. The use of like undocumented APIs and dynamic calling of functions at runtime. But no, it seems like you can use the get proc address to resolve the function address, and then branch to that address, and then this doesn't get detected by the marketplace currently. So I found one application which was using this called QuickTells. This application doesn't use it in a malicious way, but it just shows that the marketplace validation isn't as good as it could be, and that there are still gaps where an attacker could potentially get code on the marketplace. I say like the risk is quite limited. The attacker needs malware on the phone to exploit this issue, and it also needs to be an app which is vulnerable to doing something stupid with the arguments as well. So how do you protect against this? Well, basically, I see there's two methods to do this. The first is to require user interaction before allowing the action to occur. The second is implementing something like Crosssite request forgery tokens, where in the onNavigated from method, you can generate and store a token. And then in the navigated to, you can get the token data and then validate the token data passed. And finally, so just quickly, I want to talk about input validation. So an application security talk, it wouldn't really be complete without talking about cross-site scripting. So essentially, if an attacker can inject JavaScript on Windows Phone 8, if it's running, if you use a web view, then you can essentially, if an attacker injects an iframe, they can iframe content within the application sandbox, and then use this with an XML HTTP post request, exfiltrate the data outside of the sandbox, and then transmit this back to a remote server. Another interesting vulnerability I found as well while assessing marketplace applications was remote XAML loading. So XAML is used to lay out the GUI in the application and define where the controls are actually laid out on the screen. But I found an advertising app which essentially takes the XAML from a web service over clear text and then loads this XAML into the local application. So I was like, okay, well, what can you do with this? So on Windows Presentation Framework, you can embed C# code within XAML and to get code execution. But on Windows Phone 8, Microsoft have restricted this. Xcode and event handlers, they've been removed from the XAML. But I found out you could instantiate a web browser control, then you could load remote JavaScript and a remote website which has got JavaScript on, and then spoof the UI and essentially capture credentials and get code execution that way. So in summary, don't load untrusted content locally. Don't take remote content, load it in the local context without performing validation. And I don't think I really need to say this, but like remote loading XAML is a dangerous functionality. Like it's not common, but it could be in future. So in summary, I see Windows Phone 8 as one of the strongest mobile platforms out there. The kind of attacks which we've discovered through our research are mainly low-risk issues, which an attacker would need to chain together to actually perform exploitation and compromise the phone, or compromise apps on the platform. But it shows that like novel attack methods and can still be found and used by an attacker. And finally, the OEMs are still trouble. Like an OEM can still compromise the security of the platform entirely. So your choice in OEM actually dictates the security of Windows Phone 8 phones and apps. Okay, thank you. So in summary as well, I'd just like to say thanks to the previous research which has been performed and XDA forums as well, who a lot of this Appsec research couldn't be performed without the tools. There's also a white paper which me and Nick have written, which has got a lot more information in about Windows Phone 8 apps and how to securely write those applications. So, are there any questions?
Have you found that when you install the burp certificate on the phone, does it reliably work to just intercept, even with the app not doing pinning? Because I've had issues with that not working.
So, yeah, I found that sometimes it just fails entirely, and obviously because you can't overload the pinning methods, it's a pain. It's really flaky, and I've not managed to get it working reliably. And I honestly couldn't tell you what I did to get it working, but in some connections it will work, some connections it will fail. I think it's based around how the developer makes the actual request. I think through a certain path in the API it'll work, and one way it doesn't. I've not managed to get to the bottom of it yet. But
can you talk about the capabilities, and is it more like Android where it's you set it at the beginning, it's forever, or iOS where like later on you get to sort of let the user choose or whatever?
So the capabilities, you request them, you put them into your manifest, obviously same as you would in Android. They're substantially more granular than you'd find on like an Android or an iOS system. There are a lot more of them basically, until you get to the higher privileged ones like the OEM providers kind of gives you a big blanket of ability. Through the market ingestion process, it seems to clear whatever capabilities you request in the manifest, in the ingestion process, and then just analyzes your code and reassigns what capabilities your code actually uses. So the market ingestion process kind of clears out whatever you ask for. So if you ask for more than you need, it won't give you anyway.
So the MTP thing for the Samsung, can you also write to the file system? Or
Only within your local sandbox, yeah.
but after you do the exploit thing?
Sorry, was that with the FTP or the MTP?
MTP.
MTP. Yeah, with MTP you get full file system access to the system. Sorry, I thought you were speaking about using the FTP service from the Windows update. Yeah, using the MTP bug, you get full read and write access to the entirety of the file system.
Can you then put the telnet D over the MTP SRV?
Well, no, because you've got code signing which stops you running code as system. So you've only got file system access through this MTP service. You can't do that locally. So you've no way to run code as system, so you can't run anything else.